Good day to all. Today we can discuss the topic about the whale optimization. Whale optimization is mimics the whale performance. Whale performance means whale hunting performance, which is very easy to implement and it can be used for multidisciplinary engineering problems, which can be used in mechanical engineering and also in computer science, and also it can be used in electrical engineering. So it can be used for multidisciplinary engineering problems. How it mimics, here let's see, which mimics the common behavior of humpback whales bubble net feeding. What is bubble net feeding? Now I have doubt. Yes, bubble net feeding is a cooperative hunting strategy that occurs within a crowd of whales. Here a lot of diagrams, photographs are available. These are all whales. Whales generally hunting with its own crowd. It is a highly coordinated set of performance that involve communication and cooperation with each other. Then how do I convert this as a mathematical form? Let's see. So here, one of the videos I collected from YouTube, and also I mentioned the courtesy here. Whale can think, learn, judge, and communicate. The most interesting thing about humpback whales is their special hunting method. Here you see, according to this video, the foraging behavior is called the bubble net feeding method. Here, the bubble net feeding is a unique behavior that can only be observed in humpback whales. And the spiral bubble net feeding movement is mathematically modeled in order to perform optimization. So, this spiral bubble net feeding movement converted it into the mathematical form for getting the best solution in engineering problems. Here, for explaining the method, the problem I considered, the maximization of f of x is equal to x1 plus x2 square, which is the simple mathematical form. From this mathematical form, we can easily understand the procedure involved in whale optimization. Subject to the constraints, every objective function has its own constraint. So this objective function subject to the constraints 0 less than or equal to x1 comma x2 less than or equal to 1. So x1 and x2 values are lying between 0 and 1. So how do I solve? Yes, the bubble net behavior of humpback whales generally follows two approaches. Here, the first approach, shrinking encircling mechanism. Here, in previous slide, I represented about how the humpback whales are conducting their own hunting. Here, first, shrinking encircling mechanism. How do we convert that it into mathematics? Yes, according to our problem, in our problem we are having the decision variables as like x1 and x2. So how do I convert the shrinking encircling mechanism for the decision variables of x1 x2? For the reason, I generate the random number. X1 random number is lying between 0 to 1 because my objective function subject to the constraints in between 0 and 1. So here I generate the random number in between 0 to 1. So I generate the random number. In previous videos I explained about how do we generate the random numbers with the aid of calculator. The same procedure you may follow for generating the random number. Here I consider the population number of 10. So I generated 10 population numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9 and something 10. Okay, I generated the 10 or 9 population number. According to your problem, you may choose your population size. Okay. Here next, I will move to generate the random number 2 because I am having the next decision variables as x2. For the x2 also, I generate the random number between 0 to 1 because x1 and x2 are lying between 0 to 1. So I generate the random number between 0 to 1. If I am having the random number between 1 to 100 means I generate the random number in between 1 to 100. Okay, which can be also useful, easy to generate with the uh, calculator. After that, I move to next step. I found now x1 and x2 values, so that I found the objective function, which means fitness function value, which is f of x value. Near here, the x1 for the first population, x1 is 0.5499 and x2 is 0.6021. So my objective function is x1 plus x2 square. So I substitute x1 as 0.5499 and x2 as 0.6021 square. I got the fitness function of first population is 0.91245. Likewise, I got here, you see fitness function 0.91245. So similarly, I may calculate other populations also, so I can get the values of every population with the problem's objective function. So what is the next step? First approach is completed with the shrinking encircling mechanism with the mentioned procedure. Now we can move to next approach, which is second approach. So after completing the first approach, we should aware about what we do. Yes, here the objective function is maximization. So I to find which value is maximum, I compare all the 9 values with each other. From those values, 1.263384 is the maximum value from the available values. So I found which is the maximum value. Then I collect the corresponding decision variables values as like x1 is equal to 0.3135 and x2 is equal to 0.9746. Likewise, I can collect the decision variables values, which means maximum values from the zeroth iteration. So the maximum of objective function 1.263384 occurs at third population and the corresponding x1 and x2 are 0.3135 and 0.9746. From this condition, we can move to next iteration. How can we do that next iteration? Yes, second approach is known as spiral updating position. Already I shown you how do the humpback whales hunting, which makes a lot of bubbles with the water, and after that it make a spiral. From that video you may are aware. So now we move to spiral updating position of whales with this mathematical formulation. For this, first first step is to identify convergent factor, which always lies between 2 comma 0. What is 2 comma 0? Here also I generate the random number between 2 to 0. So the maximum of 2 and the minimum of 0. So I generate the random number from 2 to 0. Here you see 0.97, which is nearer to 1. After that 0.85, which is nearer to 0.97. After that 0.83. Likewise, decrementally I may generate the random number and I tabulate the same random number with the convergent factor. After that, next step, why I generate, yes, I will tell you. Here next step is R, which is random number lying between 0 to 1. Here there is no condition, you may generate a random, there is no condition, the random number is started from 2 and ended with 0. Likewise, there is no decrement or increment factor. Here you may randomly generate the numbers. Here you see the first number, random number is 0.2288, the second one is 0.3507, after that 0.4989. Likewise, the random number is generated from the calculator. After that, the next step, we have to have identify the capital A and C. Capital A and capital C are coefficient of variations. What is coefficient of variations? Let's see. Here A is one of the coefficient, which means the capital A and the C are deciding the next movement, the next position of whales. Here capital A is always lying between -1, 1. Here you see, I generate the random number from calculator. From the calculator I may get, here there is no rule for identifying the A. I can't utilize the calculator for producing the random number. Here I may utilize some formula. The formula is capital A is equal to 2a into r minus a. Here, what is a? Already I identify with the convergent factor. According to the first population, the a is 0.9781. And r, what is r? Yes, here also 0.2288 for r. After that, again, which can be subtracted with the convergent factor 0.9781. Here I can get minus 0.5304. Likewise, I may get the capital A value, which is coefficient variations. Likewise, we may identify the A value for every populations, which is not a random number, you may aware, which is generated from the formula. The formula is A vector is equal to 2A into R minus A. The same formula is utilized for other population also. After identifying the A as a coefficient variation, another coefficient variation is capital C. Here, for producing the capital C, we may utilize another formula. The formula is 2 into R. What is R? For first population, R is equal to 0.2288. I multiply the same with 2, I can get 0.457684. Likewise, I may conduct the C value identification with all other populations. I can get the values for every population as individually with the formula of C is equal to 2 into R, which is the next formula. Another step, next step, what is the column? Here P. Why identify P? Because the whales are updating its own position into its spiral pathway. So we generate this P of 0 comma 1. Here how do I identify the values? Yes, here also some conditions are available. The condition is generally P value is generated with the aid of calculator as a random number. The random number always lying between 0 to 1. Here P is 50% probability for shrinking the encircling or updating the position of whales in spiral path. So here I considered P is equal to zero point 0.5 or more than 0.5, which means P is less than 0.5. Another one is P is greater than 0.5. Likewise, I considered two conditions. What happens? Yes. Uh, Next, I will based on the P identification. Here I generated the random number in between 0 to 1. So the random number is like a 0.4011 for the population 1, 0.896 for population 2, and 0.756 for population 3. Why I identified these things? Because the whale transforming from one place to another place with the aid of spiral pathway. So capital D identification is important. Here capital D is spiral equation is employed to mimic the helix shaped movement of humpback whales, because in three dimensionally when depth increases, spiral is converted as like a helical shape. So helical identification is also important. For the reason I identify here P value. So from the P I can identify the D value, which is the updated position in spiral path. So what is the condition? Here you see the P values, first value, consider the first value 0.4, the second value is 0.8. Here the condition is P is less than or equal to 0.5. Why? How do I utilize? Yes, if the p value I got as like less than 0.5 means I directly utilize the formula D is equal to x star of t minus x of t. Here I have another doubt. What is x star of t and x of t? Yes, I can explain with the previous slide. Yes, in this slide, here you see x star of t. What is your maximum point? According to the x1, what is your maximum objective function identified? Decision variables x1 is equal to 0.3135 created the maximum fitness function. According to x2, 0.9746 is the responsible decision variable to make a fitness function as a maximum. So now we can move to the previous slide, which is here d1 is available. So x star of t, which is where I got the maximum fitness function, so I substitute the corresponding x1 value as 0.3135. X of t, what is x of t? Yes, I can explain. X of t is I conducted the iteration with the first population. So x1 value, current x1 value is 0.5499. So here I may utilize 0.5499. So I utilize this equation for identifying the D1 position, which is the position of whale in a spiral path. So D is equal to minus 2 point, I mean 0.2364 I got. I substituted the same value. For example, if I consider the second population, in second population for p value is 0.896. Here p value is greater than zero point 0.5. What is the condition? Yes, let's see. If the p value is greater than zero point 0.5, here you see 0.8964 is the p value, which is greater than 0.5. So I can utilize the formulas like x star of t minus x of t to e power bl into cos 2 pi l plus x star of t. Already in previous iteration, previous step, you may aware about x star of t. What is meant by x star of t? Where I got the maximum objective function, I fixed that value as the x star of t, and x of t is the corresponding population size. Here the second population has a greater value from p, so 0.896. So in this for this I can get x star of t as a 0.3135, which is I got from the previous step, but x of t is change of position. Here you see the x of 2, what is the x of 2? Here you see the second population is x of 2 is a 0.0682. So here I can utilize 0.0682. So 0.0682 as the uh, x of t or a second population. Here another doubt you may got, which is b. Here in the formula there is b and l available. So what is b and l? B is a constant for defining the shape of the logarithmic spiral. Here all Hubbard fails or follows the spiral path. So b is a constant for defining the shape of the logarithmic spiral. How do I assign the constant value? The spiral position or spiral logarithmic value can be started from odd number, which is 1. Then we can utilize as like odd number 2, 4, 6, 8. For examining this rule, I can utilize b as 1 as a first condition. So here I substituted b as a 1. Here you see 1 I substituted. After that l. L is a random value which can be generated from calculator or your Excel sheet. Also you may generate random numbers, but the value is lying between -1, 1. So here I place -1, 1. I generated the random number, which is 0.2845. So I substituted the value of 0.2845 as where I have the L value in the equation. Here I utilize modulus function in the equation, which is another step. Why I use the modulus function? I may get a negative value also with the equation, but if I get the negative value means I may use as a positive value, because this modulus function defining the absolute function. So if I got negative means I convert that it into positive value. Here I substituted b value as a 1 and the l value is the random number generated between -1, 1, as like I generated and substituted the same value into the available formula. Now you may aware about what is x star of t and x of t and the b l. So I substitute all the value in the corresponding equation. I may get the d value, d1 value. Here you see minus 0.2364. Here you may get minus 0.2364. So here you may utilize as like a 0.2364. Okay, and 0.313472. Likewise you may generate the other values also. Okay, here you won't consider the negative for d1. Okay, so next step, here you see you may generate the a values, the a achieved through adjusting the value of a. So this a value, already told that a value is decreasing from 2 to 0. Okay, so these steps are importantly you consider. And then d2, how do I identify d2? For identifying the d1, I used the x1 values. for generating the D2, I may utilize the x2 variables. So x2 decision variable I consider for generating the D2 values, but the procedure same as like D1, the D2 is generated. After that, here you see the a value available, but the a values are always lying between -1 comma 1. Why I consider the c here? Never I place the c. What for I generated? Yes, if suppose in a column I may have the value with more than 1 or more than -1. I mean less than -1 means how do I generate the next population or next generation of d? Yes, in the situation only when a value is greater than 1 means in this situation only I can utilize this c vector in this corresponding equation for identifying the d. In this problem I don't get the d a value as more than 1, so I substitute directly utilize those formulas and get the d1 and d2 values. But in this situation if I got a value is more than 1 means I can't utilize this formula. I utilize this formula only. So for the reason I identify c also in every population. These are all the conditions I followed for second approach, which is spiral updating position. Now you may aware about what is spiral updating position. So D1, D2 identification is the predominant step available with the second approach. After identifying all the things with the available conditions, we move to identify the next decision variable positions. Here, how do I identify the next x1? Yes, x1 is identify from this formula x t of t plus 1 is equal to x of t minus a into d. According to this, what is the previous step x value? Yes, here you see what is initial positions x value. Yes, 0.5499. So here I utilize 0.5499 for this x of t, because previous iteration I got x1 value as like 0.5499 with the first population. And what is a? Yes, I can show you. For first population, the a is minus 0.5304 I got from the second approach. Here I substituted minus 0.5304 into d. What is d? Yes, for x1 I consider that d1, so x1 value is minus 0.2364. So here I substituted the same value as like minus 0.2364. From this substitution I got the next position of whale as like 0.424495. So x1 only value I got. Similarly, I identify all other values. The same formula I utilized to identify the x2 also. Here the same procedure followed from the second column, which is x2 column. I generate the x2 values, and then I move to finding the objective function. Here I got the fitness function of second iteration. Here also I got with the maximum of fitness function with the third population as like 1.265009. Corresponding decision variable values are x1 is equal to 0.314023, x2 is equal to 0.975185. Likewise, I may conduct third with the n number of iterations. Here I consider only 2 iterations. Where do I stop my iterations? The termination criteria. If I never got the further improvement in my results means I stop that iterations, which is the termination factor available with our whale optimization technique. We can stop with the 100th iteration or 1000th iteration. When I don't get any further improvement in results means I terminate the iteration, which is the manual calculation available with the humpback whale optimization technique. We can easily utilize this technique as a tool for identifying the best parameter in engineering, multidisciplinary engineering problems. If you are having any doubts, you may ask me through comment box, and I refer the whale optimization algorithm by Syed Miraj Ali. Likewise, the journal reviewed from Advances in Engineering Software. So this journal is helpful for creating this presentation. Thank you very much. Thank you all.